as Assistant Professor in the Department of Physics, Mother Teresa Women's University, Kodaikanal from Tamil Nadu, ma'am. I am delivering my lecture. Title is Structural, Optical and Magnetic Properties of Transitions Metals Doped Metal Oxide Nanoparticles. The content of the talk is Introduction of Rare Earth Metals, Introduction of Transitions Metal, Introduction of Tin Oxide Nanoparticles, then Synthesis of Pure and Transitions Metal Doped Tin Oxide Nanoparticles, Results and Discussions. Rare earth metals. What is meant by rare earth metals? The rare earth metals are 17 metallic elements which is located in the middle of the periodic tables, which possess for the atomic number 29, 39 and 57 to 71. The parent metal is tin oxide nanoparticles. Tin oxide, which has a random, that is a great technological applications, which include sensor, catalyst, and electrocatalytic materials, and also poses for solar applications. The tin oxide, which is used to represent for nano powders and N-type semiconductors with high band gap, which is possessed for 3.6 electron volt. These are the structure of the tin oxide nanoparticles. The synthesis of tin oxide nanoparticles. This is a parent material. Different concentrations of pure tin oxide was taken, such as ratios that is 0.15 millimolar and 2 millimolar, 1 millimolar, which is represented, that is P, Q, R, S, and T with a different concentration should be mentioned here. It was the stoichiometric ratio of above mentions. Weight percentage of the material should be taken and stirred 1.5 hours using magnetic stirrers. After that, the ammonium hydroxide was added drop by drop until the pH 9 was reached. For aging process, the solutions kept at room temperatures for 1 day. The mixtures were centrifuged and washed with ethanol and distilled water several times to remove the chlorine and other ionic impurities. The resultant gel dried at 80 degrees Celsius for 6 hours. After that, it was calcined 500 degrees for 2 hours using by muffle furnace. Finally, we can collected grinding and collecting the pure tin oxide nanoparticles. Results. First, we checked the crystal structures of the as preferred pure tin oxide nanoparticles after annealing 500 degrees Celsius for 2 hours. It mentions for the structural system is tetragonal rutile structures with the space group is P42 bar M and M, which is matched with the corresponding JCPDS file number. It was mentioned in the slide. These are the concentrations of these samples, which is 1.5 millimolar, which is represented P, and 2 millimolar, which is represented, the sample name is Q, and 1 millimolar with 49 ml, that is R, and other 1 molar with 48 ml, which is S, which should be as mentioned as S, and 1 molar with 47 ml, which is mentioned as T, which has calculated for the unit cell parameters, that is 30 to 27 from P to T, which has unit cell parameter and cell axial ratio and unit cell volume should be mentioned in the table. The sharp XRD peaks indicate which is increase in crystallinity. When the dopant concentrations increases, the grain size also decreased. Optical studies. So from the optical studies, it reveals that blue shift in the absorption spectra edge of the pure samples, and it is confirms the quantum confinement effect. We are all not familiar that quantum confinement effect means that is the discrete energy level should be available, which is in bounded nanoparticles, which is should be compared to that 3.6 electron volt. Blue shift means that is the shorter wavelength. These are the Tux plot of this as Tux plot of the different concentrations of tin oxide nanoparticles. So, which is how the band gap is 3.91 for the P samples and the Q sample is 3.41. After it should be slightly decreased when compared to that first prepared sample, that is 2.71. After S and T should be slightly decreased when compared to this P and P samples, that is 3.88 and 3.69. These are the Fourier transform infrared sample FTR spectra of pure tin oxide nanoparticles. So the distinct peaks, which is observed at 1057 centimeters, which is attributed to the ammonia NH deformations, confirming the synthesis of tin oxide and integrations of this sample matrix. The intense peak at approximately 1647 centimeter inverse, which is associated with H2O bending. So the IR peaks, which is around 1101 centimeters and 2924 centimeter inverse, which is denote the vibrational modes, which is encompassing for NH stretching and organic residuals respectively. So these are the SEM studies for the different concentrations of the pure tin oxide samples. So from the various SEM morphologies of these pictures, which is give the information the spongy-like structures and deep craters, and also finally for the spherical shell formations, which is observed for the SEM studies. These are the Iraq studies for the pure tin oxide nanoparticles. So from the PL studies, we can calculate for this emissions peaks, which is around for the P samples 416 and 437 and 469, and Q sample 414, 436 and 470 centimeter, 470 nanometers. T samples, which is slightly different, that is 365, 392 and 415 and 655 nanometers. So the strong luminescence band, which is postulated to the resultant of coupling between the electron hole pair transitions from the stimulated F center to the ground state, which is due to the lower energy transitions, which is localized state. Localized states means that is the free electron movement with the higher electron hole pair recombined energy when the band gap showed prominent or deep trap state emissions. These are the magnetic studies. Magnetic studies only we can observe for the coercivity, saturations of magnetizations, and the redensity of this data only observed for S and T samples. So we have chosen for the another transition. This is previously I discussed for this pure tin oxide nanoparticles. This is the Mn doped tin oxide nanoparticles. So here the different concentrations of the tin chloride and also manganese chloride, which is which is mixed with the deionized water. The procedures was repeated. We can finally get for the Mn doped tin oxide nanoparticles. So these are the powder X-ray diffractions studies. So from the powder X-ray diffraction study, the system tetragonal retail structure should be observed from the space group P42 bar MNM, and also we can check with the standard JCPDS file number, which is mentioned in the slide. So these are the parameters and lattice parameter, unit cell parameter, cell axial ratio, which is also mentioned in the tables. So the Mn into tin oxide nanoparticle not only leads to the decrease in crystalline size, the introductions of the manganese atom into the tin oxide leads to the development of the crystal defect in the vicinity of the dopant, which is causing for the alternations of the substance stoichiometric. So this is the optical studies. From the optical studies, the manganese doped tin oxide nanoparticles, which is the absorption peak occurring at approximately 280 nanometers, which is a result for the electron transitions from valence band to the conduction band. So we can observe for this type of concentration should be increases, which is towards the rise in the absorptions. These are the Tux plot for the manganese doped tin oxide nanoparticles. The band gap of the material is also mentioned in the table. So this is the Fourier transform infrared spectroscopy. The band detected, which is for 635 centimeter inverse, which is due to the tin metal stretchings bonding with the oxygens, and 581 centimeter inverse, which is due to the antisymmetric stretching mode, which is tin and manganese to manganese bonded with the oxygen bond. There is a connections between the hydroxyls bond oscillations, and the peak appears, which is around for 1120 centimeter inverse. The existence of subsolved water, which can be explained the significant bands bounded at from 3400. So this is the water peak 3444 centimeter inverse, and also 630 centimeter inverse. This is the SEM pattern for the manganese doped tin oxide samples, which is observed the spongy like structures and also deep craters and also the clusters particles which is agglomerated to form the cluster formation should be present. So these are the pattern for the different magnifications range we have taken for the manganese doped tin oxide nanoparticles from P to T samples. So these are the EDAC studies to confirm the manganese which is present in the tin oxide matrix. So this is the photoluminescence for this manganese doped tin oxide nanoparticles. So which is the P samples we can observe for the two type of emissions, that is 366 nanometers. Ma'am,
Can
ma'am, only
you?
one slide, ma'am.
Okay.
Can I conclude, ma'am?
Yes, yes. Please
Excuse
conclude.
me, ma'am.
Yes,
Okay,
please
okay, ma'am.
conclude. Okay.
Okay, ma'am. Thank you, ma'am. In the present work, the pure and the manganese doped tin oxide nanoparticles we have successfully prepared by co-precipitations method. The powder X-ray diffractions confirms the tetragonal rutile structures of pure and manganese doped tin oxide nanoparticles. The optical studies confirm the band shift and also calculate the band gap. So the FTR determines the functional group of these pure and manganese doped tin oxide sample. The surface morphologies for the pure and manganese doped tin oxide sample studied by the SEM, and luminescence properties for the both sample studied by PL. So I must thank the final financial support provided by the DST Serve Major project, and I also thank ICRTMD to give me an opportunity to present my talk in this forum. Thank you so much, ma'am.
To all present here. I, Dr. Konika Sharma, is going to present my topic, that is recent progress in applications of superhydrophobic coatings and surfaces in various fields. So outlines of the work are introduction, synthesis of process of superhydrophobic coatings, applications, then challenges in the synthesis process, then reported work and conclusion. Moving further, introduction. So how we define the interaction of liquid with the surface on the basis of the contact angle of the liquid with substrates or the surfaces, that is hydrophilic, hydrophobic, and superhydrophobic. If the contact angle is below 90 degree, then it is hydrophilic, and above 90 degree, it's hydrophobic, and greater than 150 will become superhydrophobic surface. In nature, there are few examples of superhydrophobic surfaces, that is lotus leaves, spider webs, even pigeon feathers also show superhydrophobic surfaces. Then I come to the synthesis process of this work. There are two basic rules behind this process. That is water contact angle. Of course, we have discussed just now. Then comes the surface roughness, modification of that surface. Like as shown in the picture here, the contact angle is just, I have explained just now that the angle between the liquid surface and the solid surface is the contact angle, water contact angle. Then comes the surface roughness. Uh, when a liquid behaves with that surface, if we modify that surface in such a way that it creates asperities like shown in the figure, microstructure or hierarchical structures, then the liquid will not be able to uh, infused in that substrate we need to protect, which we need to protect. Then that is the basic rules. Apart from that, there are also some parameters like uh, uh, wettability and then surface energies that can also be considered in this synthesis process. Then various methods are sol gel, electro depositioning, chemical etching, dip coating, chemical depositioning, through which we can coat the superhydrophobic coatings over the substrates. So then here is some advantages and disadvantages of these various synthesis process. That is, if sol gel method I talk about, if a sol gel method, then and it is for complex surfaces. Obviously, high quality films can be obtained in cost effective manners. But if I talk about the disadvantage, then durability and then crackability appears in some coatings. That is the main challenge behind this. And then there are so many. For example, spin coating. Spin coating offers high quality coating. Dryness comes very easily, but thickness can be also be controlled, as we note in the dip coating process. But the surface's smoothness, or I should say the roughness process, is little bit a cumbersome task or difficult task in this process. Then moving towards the application of these super hydrophobic coatings, self-cleaning, the surface cleans itself, then it will create that kind of property. And anti-corrosion, if the metal and alloy surfaces, we can protect them. If we coat them with super hydrophobic surfaces, then we can protect them from antibacterial properties, like in sea levels. The antibacterial phenomena occur, and then we can safeguard the metals, alloys, even the structures submerged in the sea. Then solar reflective phenomena is also there. Then antifungal properties also there. Then medical properties, medical applications of the super hydrophobic coatings are also there. So basically, the super hydrophobic coating emerged as a tremendous offering a tremendous amount of applications, and so that is why they have become this they have focused they have grabbed the attention of the researchers. So challenges in the development come with, like, the surface strength, stability, as I just talked about in the soul gel method. The strength and crackability appears, then mechanical robustness or durability, that it doesn't sustain for a longer time. Then multifunctionality relevance as roughness, and one example is there of application is the surface reflectiveness. When we talk about the solar surfaces, then there is issue of synthesis process issue in the synthesis process of solar surfaces for super hydrophobic surfaces. That is, the roughness and the transparency cannot be controlled simultaneously. They have opposite effects. So that kind of multifunctionality relevance comes in the challenges. Defining new physical quantities, because it's an emerging area. So the roughness, when we talk about roughness, asperities, their profile ratios, so many physical quantities appear as a new parameters, which needs to be discussed further. Then expensive materials which are used for the super hydrophobic coatings synthesis are actually expensive. So then precipitation issue also occurs in sea levels, where we are talking about also the oil water separation method, and their precipitation issues occurs. Then air arrest issue, the asperities I'm talking about, the porous structure I'm talking about in the super hydrophobic surfaces, they offer some kind of air arrest issues. They grab the air between them, that creates the contact angle, decreases the contact angle. So that is why these are the most challenges which needs to cater before super hydrophobic synthesis, coating synthesis. Then here are some reported works for different applications. Like in the first one, they have created the super hydrophobic coating based titanium dioxide, silicon dioxide, and that they have used for the protection of stones, like for cultural heritage protection, I would say, or the stones of some castles to restore those castles. So first one and the second one is similar. Second one is also for the sandstones, limestones. They have used granite samples on which they have coated the super hydrophobic coating and protect them and restore them from some heritage purposes. And then here is the picture showing that the interaction of oil, water, and different liquids over the stone surfaces. Then here's the other work. They have also used different kind of stones like opuka, horiki. They have measured their contact angle, coated them with silicon nanoparticle coating, and then measured their contact angles with different concentration, which enhances their restoration, or which enhances their coating superhydrophobic corrector. Uh, Here theta s is basically the static contact angle, and theta a minus theta r is basically the hysteresis, contact angle hysteresis, which should be low, and the contact angle the static angle must be high, that is 150 degree, greater than 150 degree. So here is some part of our work also, in which we have synthesized superhydrophobic coating, that is functionalized TUS. TUS is trithoxyoctylsilane functionalized silica nanoparticle, which we have synthesized for corrosion protection. And we have got kind of promising results, like for steel, copper, and alloys like brass surfaces. We have got the corrosion efficiency of 95% to for 50%. 50% we have enhanced its efficiency to protect it from corrosion. So these are the SEM pictures of our work. That is, they are showing the hierarchical structure, that is nanoparticle and microstructure infused in the coating, and that is coated over the metal or alloy surfaces. Then another work, that is some like cost effective route they have used. The method they have used is electro depositioning, and the contact angle they have achieved is 162 degree, and they have used it for photocatalytic properties, like application of photocatalytic, like visible rays or UV rays they have studied over it. Then zinc oxide is used to prepare nanorod surfaces with self-cleaning. They have used it for the application of self-cleaning. Now, even the coating they have shown, as is in the picture, the flower-like structures are water and oil repellent properties with high mechanical resistance. So, uh, then another examples of reported works, like self-cleaning purposes they have used for antibacterial surfaces. Some work have been reported, and they have demonstrated the reverse structure effect of antibacterial upper layer, antibacterial anti-fouling properties also. Then even if I talk about the MS Salim at reported work, that they have acquired a quite high angle of contact angle, that is 165 degree, and that's with the high thermal stability, and UV under UV radiation they have checked it, or and their stability and offers good durability also, that cater the basic challenges of superhydrophobic synthesis. This is the same picture I have just discussed as here, the antibacterial surfaces, how they behave with after coating that surfaces with the superhydrophobic coatings, the how they behave with bacterias, how they started killing or contact killing, and that this picture shows the same effect. Now, talking about different applications in different fields, like textile industry has self-cleaning properties they can use, then antibacterial properties of superhydrophobic coatings are useful for them also. Then coating industry for just like anti-corrosion uh, anti-corrosion effects, then constructions in the construction areas, self-cleaning, photocatalysis walls, stones and building material. I've just presented the examples. Then automobiles, but there are some requirements for these applications also. Like for if I'm talking about the antibacterial coatings, then we need a high biological activity also, and weather resistance should be there. Then, if I talk about the energy coatings, for example, solar cells, transparent coatings, then mechanical resistance, water resistance, the weather resistance, because they need to, expose in the hard weathers also, harsh weathers also. Then in aerospace, we can also apply these kinds of applications, like low surface energy or always needed for the superhydrophobic coatings. Then low toxic behavior should be there. Then thermal resistance is also required. So basically, these are the application which we can, these are the various areas on which superhydrophobics can be applicable. Moreover, the requirement is different or similar to their properties also. Basic properties will be same, but there are some kind of requirement on the basis of the applications also. Like for, as mentioned, like for solar cells, there is need of weather resistance. And then for, if I talk about textile industry, they will need the flexible biological activities. They will also need high biological activities. They also need. So that depends what are the application and what are the requirement. Um, Concluding my work with this, that super hydrophobic coatings actually have few parameters to, controlled parameter on which we can control those parameters, and we can synthesize super hydrophobic coatings. Things like wettability, surface energy, contact angle we just discussed. But then before that, we need to think about the challenges we are going to face. If we need to just make the super hydrophobic coating, or we need to make it durable, or we need to make it for corrosion, for metals, for alloys. That those are the basic kit need to be that basic requirements that need to be catered. Then techniques, there are a lot of techniques as we have already discussed, and sol gel techniques, electrodip. Sol gel is quite cost effective technique also, dip coating, and then exhibit various properties also, like we have discussed. Even if I talk about the materials, they have so many, there are so many materials as new organic materials which are being used for synthesis of super hydrophobic coatings, like as shown in the exam as
Good
example.
evening to all. Myself, Dr. Krishna Prabhayam, Associate Professor, Department of Physics in Dr. P. Dayanand Pai, P. Satish Pai Government First Grade College, Mangalore, Karshid. I'm going to present the work which I have carried as a curiosity, the synthesis of silver and gold nanoparticle using Syzygium samarangens fruit extract as reducing agent and their application in the reduction of 4-nitrophenol. Uh, my outline will be introduction, experimental part, characterization, results and discussion, and conclusion. As we know, silver, argentum, and gold, aurum, are the noble metals with atomic numbers 47 and 79, and both have face center cubic crystal structure. Nanoparticles of Ag and Au are used in various applications like nanoelectronics, therapeutics, catalysis, biosensing, bioimaging, dyeing of fabrics and leather, etc. Immediate observable property of the aqueous colloidal dispersions of noble metal particles like gold and silver is a range of attractive colors. The aqueous solution containing the silver nanoparticle will be in the shades of yellow, brownish yellow, and so on, whereas the aqueous solution containing the gold nanoparticle will exhibit colors, attractive colors having ruby red, pink, violet, etc., depending on the size and shape of the particles and also the nature of the solvent. So the optical properties, which are the special property of noble metal particles, they originate from surface plasmon resonance. And here, interaction of electromagnetic field with conduction band electron results in coherent oscillation of electrons. So there are different synthesis methods for obtaining Ag and Au nanoparticles, various physical methods, chemical methods available, but I have gone for this biological method because it's a cost-effective method and it's not using the strong reducing agent like sodium borohydride or trisodium citrate. So there are many studies reported using various parts of the flowers or fruits, etc. I have used this particular fruit. This is called Syzygium samarangens. It's also known as wax apple or water apple. Some call it as Java apple also. It is an edible fruit having lot of medicinal value and it belongs to the family Myrtaceae. And why this plant I have chosen? So this plant is known as a rich source of tannins, flavonoids, anthraquinone, etc. And it exhibits pharmacological properties like anti-cancerous, anti-diabetic, antimicrobial, antioxidant property. And it is used in making of jams, jellies, candies, etc. And it is also used to treat high blood pressure and several inflammatory conditions. There are reports of biosynthesis of these nanoparticle, both Ag and Au, using the leaf extract and flower extract in literature. And I have chosen this particularly just to out of curiosity because when I was carrying out my research work on porous nanoparticle of gold, uh, I had to use silver nanoparticle as the starting material. So that time I just thought, uh, Okay, let me see the synthesis of various these nanoparticle, silver or gold, using different parts of the plants which are available in backyard. So synthesis and characterization. So fruit extract, this is a very crude method. Fruit extract was prepared by boiling known quantity of fruit in 30 ml of double distilled water. And to prepare the gold nanoparticle, 4 ml of the fruit extract was added to 16 ml of aqueous solution containing HAUCl4 under stirring. It was conducted at room temperature. And for the synthesis of Ag nanoparticle, the same method, but it was heated. And in case of synthesis of gold nanoparticle, rapid color change within a minute was observed, whereas Ag nanoparticle, it took the time required for boiling. And the synthesized nanoparticles were characterized using UV spectroscopy XRD FESEM, which is equipped with IRAX. And these particles were used as catalysts in the reaction of 4-nitrophenol, which is an organic pollutant from industrial waste and also exists as a metabolite in a bacteria called E. coli. UVV studies actually provide an important information regarding the shape, size, monodispersity, etc. Uh, Let me go to the results. So here you can see the UVV's spectra, absorbance spectra of both Ag and Au nanoparticles. Uh, this one, the graph numbered 1, it represents the UV's absorbance spectra. So it contains a single peak, single surface plasmon resonance peak. Therefore, it is indicative of spherical nature of the nanoparticle, and the peak was obtained at 448 nanometer for Ag nanoparticles, and the solution had brownish yellow color. And the aqueous solution containing the gold nanoparticle, it exhibited a peak at 541 nanometer, and the solution appeared purple. So both these suggested the formation of spherical shaped nanoparticles. And then we have done, we in the sense myself only, because this was just made of these studies were out of only curiosity, XRD studies, and both in cases of silver and gold nanoparticle, I got a prominent peak at 111 at angle of 2 theta is equal to 38 degree. And this corresponds to 111 plane of face-centered cubic structure, thereby both uh, exhibited the crystalline structure. The FESM studies were done just to see the shape of the nanoparticle, and this represents the FESM micrograph of Ag nanoparticle. And almost all the nanoparticles were spherical, but here we can see the polydispersed nature, and all the particles were found having their size less than 50 nanometer. And the IDAX represented the presence of elemental silver, and which is confirmed by the peak at 3 keV. Next, the AU nanoparticle. This shows the FESM image of AU nanoparticle, and here also almost spherical shaped nanoparticles were found, and the appearance of AU peak was observed at 2.20, 8.4, and 9.6 keV. This confirmed the purity and the elemental composition of synthesized gold nanoparticles. And I have used both the silver nanoparticle as well as the gold nanoparticle in the reduction reaction of 4-nitrophenol. 4-nitrophenol is a toxic pollutant found in the industrial waste. Uh, just to have the wastewater treatment in which the 4-nitrophenol is present, it can be converted to a useful product called 4-aminophenol, uh, which is used in preparation of analgesics, paracetamol, and so on. Actually, this graph represents the reduction reaction of 4-nitrophenol. Usually, even with the strong reducing agent like sodium borohydride, the reduction reaction of 4-nitrophenol will not proceed. But after adding a little amount of catalyst, the reduction reaction of 4-nitrophenol proceeds, and it completes within, in my case, here I have found it, the reaction process was complete uh, after 25 minutes. So here you can see, this is the P corresponding to 4-nitrophenol, the graph number 1. And after the addition of sodium borohydride, due to the formation of 4-nitrophenolate ions, the peak gets shifted to 400 nanometer. And if the nanoparticles are not added, this will stay here only. But after even after a day also, it remains here only. But after the addition of the nanoparticles, that is a gold nanoparticle, we see a concomitant decrease in the intensity of this 4-nitrophenyl tie-in, and at the outset there is one more peak emerging out which corresponds to the 4-aminophenol, and the entire reduction reaction of 4-nitrophenol was complete within 25 minutes. And one more important thing I found is, though the Ag nanoparticle also acts like a catalyst, the silver nanoparticle did not show the reduction reaction of 4-nitrophenol, which is actually a mystery for me, because the gold nanoparticle showed the catalytic activity in the reduction reaction of 4-nitrophenol. And the conclusion, both Ag and Au nanoparticles are synthesized by reducing the silver nitrate and chloride solution using the fruit extract of Syzygium subrangens fruit extract. And actually, the gold nanoparticles were not so stable, whereas the silver nanoparticle produced using the Syzygium subrangens fruit extract is having long stability. Even after 5 to 6 years also, the nanoparticle solution is stable. And one question that is left in front of me is why the reduction reaction did not proceed with the Ag nanoparticles. This is my small presentation where I have prepared the silver and gold nanoparticle and studied their catalytic activity using a biological method. Thank you.
Good afternoon. My name is Kudzaya Mishruzidzo from the Delhi Technological University, and I'm here to present on my presentation titled Spectroscopical, Chemical, and Electrical Properties of Novel Organic Draw Solutes for Forward Osmosis Desalination. The first objective was to identify novel draw solutes with high osmotic pressures. Then the second one was to test their rheological, physical, thermal, spectroscopic, chemical, and electrical properties. Now, the word desalination, the word D means remove. So desalination is a process that separates dissolved salts from water. As you can see from that table, nearly 97% of the available water on Earth cannot be drink because of high salinity. And when we talk of salinity, the World Health Organization allows a permissible limit of around 500 to 1,000 parts per million. But seawater is a salinity of over 35,000. And there's what we call brackish water, which is which is high salinity than fresh water, but less salinity than seawater. Now, as you can see from that diagram, the first one on the left, top left, that's in Africa where I come from. The second one is from India, and the other one is from Asia. We can see that according to the West Bengal government arsenic task force chairman, they are saying that by tomorrow is the 2024. By 2025, they are saying that nearly 2/3 of the world population will be living in areas under high water stress conditions. I'm from Zimbabwe. Right now, my country is facing some cholera outbreaks because of unsafe water sources. So the world has moved on from COVID pandemic, but us countries from the global south are still facing problems of fresh water. And forward osmosis, this is a membrane separation process. As we can see, seawater containing some salts is then put in a semi-permeable membrane. Then on the right side, we have what we call a draw solution, which has high osmotic pressure. So the difference in osmotic or the osmotic gradient is the driving force for forward osmosis, unlike reverse osmosis when there's some external pressure. And then the top right, this is the lab setup, self-assembled the forward osmosis setup I made Then on the bottom left, that is the membrane, the forward osmosis commercial membrane with some spacers to reduce what we call external concentration polarization. And these are some of the properties of those membrane. Now, in this research, we are using organic draw solutes, and they were binary, they were a mixture of a cellulose derivative. The cellulose derivative was either hydroxypropylcellulose or sodium carboxymethylcellulose with a glycoether. And these are the densities and the dynamic viscosities, the pHs, the electrical conductivities, but most importantly, the osmotic pressures in the far right. These are for the nomenclature. 0.5 means 0.5 weight% of the hydroxypropyl cellulose, then 7.5 molar of the glycoether, then they were mixed together to give us our draw solutions. Then the cloud point determination, this was you to determine what we call the LCST, the low critical solution temperature, because below that temperature, there will be there will be miscible. Above that temperature, there will be immiscible. And this information is important because there's a second step. When you look at forward osmosis there, they consist of the first step is the osmosis, the permeability of water through the permeable membrane. But the second step, there's the regeneration, in which the diluted raw solution is to be regenerated so that we may collect water and it may be used to again. So this cloud point determination helps us when we can see where there's separation of the phases. Then the dynamic viscosities of the pure cellulose derivatives were determined using an Anthony Per MCR302. And as we can see by themselves, cellulose derivatives or carbohydrates per se, they've got a high molecular weight, therefore they've got a high viscosities, as can be shown here. But when we add the glycoethers, as you can see at 25 degrees, now these are the binary solutions. We can see that the dynamic viscosities are greatly reduced. And also, as we move from 25 to 30 degrees, because the viscosity decreases with temperature, they are further reduced. Then the thermal stabilities of those draw solutions were characterized using a TGA. And as can be seen, we had one solution for comparison, which did not contain the glycoether, and that was the most thermally stable. But and also those ones containing the sodium carboxymethyl cellulose, both at 1 weight% and 2 weight% with the glycoether, they had the identical profiles. Then those made from hydroxypropyl cellulose, they had the most substantial degradation. And from these, the one containing 1 weight% carbon sodium carboxymethyl cellulose and the glycoether, it was the most thermally stable one. Then the osmotic pressures by themselves, the 1 weight sodium carboxymethyl cellulose is only 0.655 bar, which is not in use in forward osmosis. Then the 7.5 molar glycoether, it is 69 bar, which is very, very wonderful. Then the combined one, it 34,262 bar, which is good enough for forward osmosis desalination of brackish water. Then comparing therefore the FTIR, as we can see, the final spectrum of the combined binary solution is just a combination of the single spectra of these, meaning that we can separate them by physical means. Then these are some of the properties of the individual cellulose derivative and the glycoether. Then they combined, we're comparing them, their pH, their electrical conductivities, their total dissolved salts, their salinities, their resistivities. And we can see that by combining these two, the properties in the final draw solution of the binary solution, these are greatly changed. Then, as I showed you the setup, this is the most important factor when we now have to do the actual readings. And the experiments were for 2 hours, and the red line, red line was modeled. We used the MATLAB software, and we used what we call the solution diffusion model to try to predict the solid fluxes and the water fluxes. So those are represented by the red, and then the black, these are the actual experimental water fluxes, and the difference, according to literature, they may be due to the uh, combining of what we call the biofouling effects. So, in concluding, out of our initial draw solution, we had 30. 12 of them had osmotic pressures that exceeded 25 bar. Then out of those 12, we chose 5 for further work. And from those 5, we characterized them. There are especially two important factors, the osmotic pressure and the dynamic viscosities. And the 1 weight% HPC with the glycoether and the 1,5, okay, all those containing hydroxypropyl cellulose are not feasible. Is there high dynamic viscosities, and also they formed some lumps. But from these results, the one containing 1 weight% sodium carboxy methylcellulose and 7,5 molar glycoether produced the best results. And in this case, we're desalinating 1000 ppm sodium carboxy, sodium chloride feed solution.
Good afternoon to
thank
all of you. I am a Mr. Kuldeep Padiyar from research student and associate professor in Department of Chemistry, MGBs, Maharaja Sayajirao Gaikwad Mahavidyalay, Malegaon Camp, Malegaon District, Nasik. Today's I will present my paper Synthesis, Characterization and Computational Studies of the Meldrum Acid Chalcone Derivatives by using the green base. The abstract, the current inspections agreements with the detailed investigations on the computational studies of the Meldrum acid chalcone derivatives by using the density functional theory DFT and the enlarged molecular geometries, bond angle, bond length, bond atomic charges of the title compound have been investigated by the DFT study by using the standard B3LYP methods 321 plus G basic sets using the 16W package, and the HOMO-LUMO transition implies an electron density transfers. The introductions, the structural essence of Meldrum combined with the single properties has made with this adaptable reagents in organic synthesis, and the CH2 group of Meldrum acid is placed in between two carbonyl groups shows the more acidic properties and configurations of approach to hypothesis carbon-carbon linkage in organic compounds, and the condensations of various derivatives of aldehyde compounds and Meldrum acid is catalyzed by the different bases such as the piperidine, pyridine through novel condensations of the Meldrum acids. This is my synthetic scheme. So
Sorry, Kuldeep, sorry to interrupt you. Actually, your slides are not moving.
slides.
Still, yes, it is still in the first slide only.
Okay, sir.
That is it. You can click on the slide mode.
Okay, sir.
You can start with the slide mode. No, at the below right hand corner there is a slide mode. Is there? No.
Yes, yes, yes. I know, sir.
One more thing, Dr. Kuldeep, kindly
Huh?
switch on your camera.
Yes, ma'am. Okay, ma'am. Sure, sure. Yeah, then scheme, this is my scheme. The Meldrum acid and substituted aldehyde with 1:1 equivalent molar ratios, along with the ethanol as a solvent and natural base, and formation of the formation of the title compounds. And I take the two different derivatives, and the yield of this molecule is when electron donating group is attached, then yield is more, 90% yield is I have got. Then I take the computational investigation, that is a density functional theory. Computational chemistry is a branch of chemistry that uses the computer simulations to assist in solving the chemical problems, and it uses the method of theoretical chemistry incorporated into the computer program to calculate the structures and properties of the molecular groups. By using DFTs, I determine the optimized geometrical parameters such as the bond length, bond angle, dihedral angles of synthesized compounds, and also determine the Mulliken atomic charges from optimized geometry of the compounds. Then analysis of thermodynamic stabilities by computing thermodynamic parameters. Also calculate the HOMO and LUMO energies with their energies gap. Then the calculate the electronics properties by evaluation of global reactivities parameters. That is electronegativity, absolute hardness, softness, electrophilicity, chemical potential, and maximum number of electron prefers to then analyze the stability and reactivity of synthesis compounds by frontier molecular orbitals, FMO, and molecular electrostatics potential analysis. Then to also study the effect to different solvent on the spectroscopic properties of the synthesized compounds. Then this is I take the one data, one spectra by using the computational data, computational chemistry. This is my characterization of the compound B derivatives. This is my FTIR. This FTIR shows the two different carbonyl stretching frequency. One is a 1748 and another is 1754. And then aromatic hydrogen, it shows the 3240. Then carbon-carbon double bond in benzene ring is 1600. And substituted aromatic shows a 685 centimeter inverse. Then this is the H1 NMR for my title compound. Then this is a optimized geometry. This is my another data of HOMO and LUMO data. Actually, the optimized structures of the title compound has been calculated the molecular electrostatics potential and HOMO-LUMO energy by Gaussian's 16W software. 16W software at B3L by P 6311G basic levels. By using the optimizer geometry is procedures that attempt to find the configuration of minimum energy gap. And the theoretical study, we have to shows the electron donating and receiving ability of the molecules can be defined by the HOMO and LUMO energy. HOMO means higher occupied molecular orbitals, and LUMO means lower unoccupied molecular orbitals. So this is my optimized geometry along with label, and this is my HOMO and LUMO structures. In HOMO and LUMO structures shows the green color and red color orbitals. They are the orbitals. The green color orbital shows the negative phase, and red color orbital shows the positive phase present in the molecules. Positive phase present in the molecules. Then this is the HOMO-LUMO energies for my both compounds. The compound A and compound B. This first compound A shows the HOMO energy gap is minus 0.2547 and LUMO energy gap is 0.0953, and its energy gap is 0.1594. And this is another derivatives. This and its energy gap is the 0.1549 electrons volt. Then next is the Mulliken atomic charges in gas phase of the compound B's. Compound B, my optimized structures which are having the presence of the atom is carbon, oxygen, and hydrogens. The Mulliken atomic charges of the carbon atoms where exhibits either positive or negative values. All hydrogen atoms were displayed the net positive charge, but in net positive charge. So in our datas, the H13 shows the higher charge value because this is close to the electronegative atoms, electronegative atom. So close to the electronegative atoms. Then hydrogen atom shows the close proximity to electronegative oxygen atom. And besides all oxygen atoms, atom of optimized compound shows the negative charge, and that acts as a donor atoms. Then the Mulliken atomic charges also gives the geometry of the optimized compound. Then conclusion: the protocol for the synthesis of compound reported herein is efficient and efforts product with a desirable yield. Workup and isolation of product is easiest, and all spectra are identical matches to the structures of synthesized compounds, and geometrical optimization for non-planar geometry with C1 point group symmetry. Then also shows the green protocol for the synthesis of heterocyclic derivatives, and smaller the homo-lumo gap indicate the higher reactivity with lower stability of synthesized compounds. And this is the conclusion. Then acknowledgement, authors to thankful to respected Dr. A.P. Hire sir, coordinator of MGV Nasik, principal of Dr. C.G. Digavkar sir, vice principal, and HODs, Dr. T.S. Saure sir, MSG College Malegaon, providing the laboratories facility. I am also thankful to my research supervisors, Professor Dr. Ramesh Nirwan, for guiding me through the research, and I am also thankful to DSTP sponsor Department of the Chemistry, MSG College, for providing the instrument or Gaussian software facilities. These are the references, and thank you.